Good day everyone, my name is Christian. In this presentation, we will be exploring photodetectors, which are devices that allow us to detect and measure light by converting it into an electrical signal. So photodetectors are everywhere and they are around us. They are found in cameras, automatic street lights, fiber optic communication systems, medical imaging devices, and even smartphones. With photodetectors, modern optical technology simply would not exist. So today we will be discussing what photodetectors are, how they work, the different types of photodetectors, their key performance parameters, and their real-world applications. So by the end of this video, you should have a clear understanding of how light becomes an electrical signal. So a photodetector is an electronic device that senses light and converts it into an electrical signal, such as a current or voltage. The operation of photodetectors is based on the interaction between light and matter. When photons strike a sensitive material, they transfer energy to electrons. If the energy is sufficient, electrons are excited or released, producing an electrical response. So this process is closely related to the photoelectric effect, where light energy is converted directly into electrical energy. The stronger the light intensity, the larger the electrical signal is produced. So in short, photodetectors act as a bridge between optical signals and electronic systems. So let us now look at how photodetectors actually work. So most photodetectors operate using semiconductor materials such as silicon. When light enters the detector, it is absorbed by the semiconductor and creates electron-hole pairs. So in devices like photodiodes, an internal electric field usually formed by a p-n junction separates these charges. So this movement of charges results in a measurable photocurrent. So the key idea here is very simple. No light, so which means very small or no current. More light means larger current. So this relationship allows photodetectors to measure not only the presence of light, but also its intensity. So photodiodes are the most commonly used photodetectors. They are fast, reliable, and widely used in optical communication and light measurement systems. Photodiodes can operate different modes such as photovoltaic mode and photoconductive mode, depending on the application. So also phototransistors are similar photodiodes but offer internal amplification. This means that they produce a larger output signal for the same amount of light. However, this comes at a cost of slower response time, making them less suitable for high-speed application. So photoresistors, also known as light-dependent resistors, change their resistance depending on light intensity. They're inexpensive and commonly used in automatic lighting systems, but they are slow and less accurate compared to semiconductor photodetectors. So avalanche photodiodes operate at high electric fields and use an avalanche multiplication process to amplify the signal. They are extremely sensitive and are often used in low light detection and fiber optic communication systems. To evaluate photodetector, we look at several important parameters. So responsivity, how much electrical output is produced per unit of light input. Spectral response, which wavelengths the detector is sensitive to. Response time, how fast the detector reacts to changes in light. And lastly is the noise, unwanted signal that limit detection accuracy. Choosing the right photodetector depends on matching these parameters to the application. So photodetectors play a vital role in many technologies, such as optical communication, converting light into signals, um, converting light signals into electrical data rather, and medical imaging, such as X-ray and optical scanners, and then consumer electronics, such as cameras, smartphones, and remote controls. They also use it in industrial automation, like object detection and safety systems. And lastly is the environmental monitoring, such as light, radiation, and chemical sensing. As technology advances, photodetectors continue to become faster, smaller, and more sensitive. So in conclusion, photodetectors are essential devices that convert light into electrical signals, enabling modern optical and electronic technologies. By understanding how photodetectors work, their different types, and their performance characteristics, we can better appreciate their importance in science, engineering, and everyday life. Thank you for watching, and I hope this presentation helped you understand the fascinating world of photo detectors.